Okay. So, hi everyone. So, good afternoon all. So, first of all, let me know whether audio and video everything clear. So, good afternoon all. So, first let me know whether audio and video everything clear. Yes. Yes. So, is audio and video everything clear here? So, if it is clear, then we can start the session here. So, first of all, let me know whether audio and video everything is clear or not, right? Okay. Okay. So, I hope it is clear. So, we are dealing with the subject electromagnetics, right? And we have started the topic. That is electric field, right? So we have started the topic electric field. Okay. 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 So in the previous session, we have seen I have defined sorry. So I have defined what do you mean by electric field, yes or no? So electric field is defined as what here? Electric field is defined as the force experienced. The electric field at any point is defined as what? The force experienced by a unit positive charge at a point will give you the electric field strength at that point, yes or no? Okay. So the electric field strength at a point. So what I have said here, the electric field strength at a point is a measure of what? Is a measure of force, experienced by a unit positive charge. At that point, yes or no? Okay. So this is what we have defined. So the force experienced per unit charge is called as what here? Is called as electric field. It is going to give you electric field strength at that point. So in general, we can represent electric field as what here? It is nothing but the force experienced per unit charge, and hence its units are nothing but what? Its units are nothing but Newton per Coulomb. Right. Okay. So the direction of electric field and the direction of force both are going to be in the same direction, right? So these things we have seen here, So I said that whenever you place a charge Q, it is going to set up some electric field in its vicinity. Yes or no? How do we know that it has set up some electric field in its vicinity here? So whenever you try to take any charge, let us say test charge into this field, this test charge is going to experience a force, yes or no? So that means this field is exerting some force on that particular charge. Understood? So if there exists any field, then that field is going to exert a force on this charge, So what is the force it is going to experience here? So the force it is going to experience is nothing but Q by K into R square. So this is the force that is going to experienced by this Q amount of charge. So if this is the force that is experienced by Q amount of charge, then what is the force per unit charge here? Force per unit charge F by Q is nothing but what? K into Q by R square. So this is what we have defined as what here? Electric field, the force experienced per unit charge, right? Okay. Okay. So next. So next, based on this, we have solved some problems, right? So we have solved some problems here. So what are the problems that we have solved here in the previous session? So we have taken different charge configurations, yes or no? So we have taken 1 nanocoulomb here and another 1 nanocoulomb here. So we have considered this point as 1, 0, 0, this point as 4, 0, 0, and we try to determine the point where the net electric field is becoming equal to 0. And in the second problem, we have considered 1 nanocoulomb here and another one as minus 4 nanocoulomb. Another one as minus 4 nanocoulomb. So this is also located at 1, 0, 0, and here this is located at 4, 0, 0. So where the net electric field is becoming equal to 0, right? So that point we have determined. So next, what is the problem? Next problem we have taken here. What is the next problem we have taken? So next one is we have considered some 1 nanocoulomb here and then 4 nanocoulomb here, right? So we try to determine the point where the net electric field is becoming equal to 0 for this problem. So next we have taken another problem here. So that is, we have considered here 1 nanocoulomb and another one here we have considered minus 1 nanocoulomb. So this is located at 1, 0, 0, and this is located at 4, 0, 0. So for all these charge configurations here, we try to determine what here? We try to determine the point where the net electric field is becoming equal to 0. Yes or no? Okay. So these are the problems that we have solved in the previous session, and we have observed that for this configuration here you are having 1 nanocoulomb and here you are having minus 1 nanocoulomb separated by some distance r, right? Okay, separated by some distance r, right? So here it is just like what here? It is just like plus q here and here minus q separated by some distance r. So it is just acting like what here? It is just acting like a dipole, yes or no? So if you take plus q and minus q separated by some distance r, then it is going to act like what here? It is going to act like a dipole, yes or no? So here this is 1 nanocoulomb and minus 1 nanocoulomb separated by some distance r. So it is going to act like a dipole. So we have seen that due to a dipole, you cannot find out a single point in space where the electric field is becoming equal to 0. Yes or no here? So we have seen that due to this dipole combination, you cannot find out a single point in space where the net electric field is becoming equal to 0, right? So these are the things we have seen in the previous session. See, for all these problems we have determined the point where net electric field is becoming equal to 0. Yes or no? Okay. See, I have told that if both the charges are of same polarity, then the point must lie between what? Between the 2 point charges. If both are of opposite polarity, then the point must lie either to the right of this charge or to the left of this charge. Yes or no? Okay. So that's what I have told here. So based upon that, we have determined where the net electric field is becoming equal to 0. Understood? We have determined this point here in all the cases, but we have observed that in fourth problem, we cannot find out a single point in space where the net electric field will become equal to 0. Understood? Okay. So these are the things we have seen in the previous session, right? Okay. Okay. So now let us consider this as x-axis, right? Okay. So So this as y axis, this as y axis, right? Okay. So this is x axis, y axis. Now let us consider a point here. Let us consider a point here. So let us say this point is 1, 0 here. Let us say this point is 1, 0. So here let us consider this point is 0, 0, and this point is minus 1, 0. Right. Now let us assume here you are having a charge q. Here also you are having a charge q. Right. Now what is the field? What is the field at this point? So this point is, let us say, 0, 1 here. Okay. So determine the field at this point. So you have placed a charge q at minus 1, 0. Another charge q is placed at 1, 0. Right. So another charge q is placed at 1, 0, and here another charge q is also placed at minus 1, 0. Right. So this charge is placed at 1, 0. This is placed at minus 1, 0, and now they are asking to determine the net electric field at point 0, 1. What is the net electric field at point 0, 1? So here you have to determine the net electric field. Determine the net electric field at point at 0, 1. At 0, 1. Okay. So this is the question they have given here. So you have to determine the net electric field at this point 0, 1. So what they have given here? They have given a point charge is located at minus 1, 0. Another point charge is located at what? 1, 0. Right. And you have to determine, they are asking to determine the net electric field at point 0, 1. At 0, 1. So so what is the answer for this question here? Tell me. So how to do this one? See here. See. It is very simple question here. See here. So if you want to determine the electric field at this location due to this charge and due to this charge, see here. So the electric field due to this one here, the electric field due to this one is going to point in this direction. Let us name it as Q1. Let us name it as first charge, and let us name this as second charge. Right. So this electric field I can call it as E1 bar. Now similarly this Q2, due to this Q2, the electric field at this location, is going to point in this direction. So let us say this is E2 bar, right? Okay. Now if you observe here, this E1 bar is neither along what here? This E1 bar is neither along x direction nor along y direction. So you can resolve this E1 bar into two components. One is what here? One is along x direction, and another one is along what? Another one is along y direction. Similarly, this E2 bar is also neither along x nor along y. So you can resolve this into what? You can resolve this into two components. One is along x direction, another one is along what? Another one is along y direction. Understood? Now if you observe here, this component, this x component of E1 and the x component of E2, both are what? Both are exactly opposite to one another. Yes or no? Okay. So these two will get what here? These two will get cancelled, and the y component of E1 and the y component of E2 both are in the same direction, that is in y direction. Yes or no? So these two components are going to get added up. Right. So that means the net electric field at 0, 1 is going to have only which components here? The x components of E1 and E2 will get what? Will get cancelled, and the y components, only y components are getting added up. So the net electric field you are going to have in which direction? You are going to have only in y direction. You are going to have only in y direction. Right. Okay. 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 So now see here. So now what is this angle here? What is this angle? Tell me. What is this angle? See, the distance from here to here. The distance from here to here is 1. and the distance from here to here, the distance from here to here is also 1. Yes or no? From here to here it is 1, from here to here it is 1. So this angle theta will become equal to what? This angle theta is equal to 45 degrees. So this angle theta is equal to what? This angle theta is equal to 45 degrees, right? Yes or no? Okay. So now this component is nothing but E1 cos 45 degrees, and this component is nothing but E2 cos 45 degrees, right? And this component here, this component is nothing but E1 sin 45 degrees, and due to E2, the y component of E2 is nothing but what? E2 sin 45 degrees, right? So we have seen that these components here, these x components will get what? Will get cancelled, and and this y components will get what here? Will get added up. Okay, so what you are going to get here? So what are the y components? E1 sin 45 and E2 sin 45. See, we can observe that the magnitude of E1 will be same as what here? The magnitude of E2. Yes or no? The magnitude of E1 will be same as what? The magnitude of E2. Yes or no? Because the distance from here to here and the distance from here to here, both are what? Both are same. Here you are having Q, here also you are having Q, right? So that means the magnitude of electric field due to this point charge at this location and the magnitude of electric field due to this point charge at this location, their magnitudes will be same. Yes or no? So that means here, see here, so so that means here so here what are the components that are adding up here? E2 sin 45 and E1 sin 45. So that is E2 sin 45 plus E1 sin 45. So both are adding up. Yes or no? Both are in the same direction, that is in AY cap direction. Now here E1 is same as what here? E1 is same as E2. So you can write it as simply 2 into E1 into sin 45 degrees into AY cap, right? Okay. Excuse me, sorry. Okay. Okay, yeah. So now what is E1 value here? So E1 is nothing but what? E1 is nothing but the electric field due to this Q1 charge. So what is the electric field due to Q1 charge? E1 is equal to Q1 K into Q1 divided by what? Divided by the distance from here to here. So what is the distance from -1, 0 to 0, 1 here? What is the distance? So distance is nothing but what? Root 2 or not? Yes or no? The distance between -1, 0 to 0, 1. What is the distance? Distance is nothing but root 2. Yes or no? So you will get K into Q1 by root 2 whole square. So this is the magnitude of what? This is the magnitude of E1. So just substitute this one here. So what you are going to get? So 2 into K into Q1 divided by root 2 whole square is nothing but 2. So sin 45 is 1 by root 2 AY cap. So here 2 will get cancelled. So therefore the net electric field is equal to what here? Is equal to K value is how much? 9 into 10 power 9. You can substitute that, no problem. Okay. So you will get simply K into Q1 divided by what? Divided by root 2 AY cap. So this is the net electric field. At this point here. So due to these 2 point charges, the net electric field will be equal to what? The net electric field will be equal to K into Q1 by root 2 AY cap. Right? Okay. Okay. Okay yaar, see I was not feeling well, so I'm getting okay. Okay, so I'm not feeling well here, so I'm getting cough. I'm not able to hold that. Okay, so I'm feeling like I will wind up the session today here, so I will continue from tomorrow, right? Okay, so I'm winding up the session here today, so because I'm not feeling well, right? Okay, so tomorrow exactly at 4 p.m. we will meet again. Exactly at 4 p.m. we will meet again. So sorry for the inconvenience here. Okay. Okay. So today I am winding up the session here. Okay. Okay.